Okay, good evening. Can you hear me? Hello. Hello, can you hear me? Hello.
Yes, sir.
Okay, just waiting some minute, then we'll start. Okay, so we will start today's session. So basically, today is our third number test. Okay, and okay, so we will start. I think some people are not joined yet. Okay, so I hope they are also joined. And if are not joining, then they can easily get the recorded class and also complete this session. No problem. Okay. So we will start our class. So let me share my screen. Okay, is it visible? Okay, can you see my screen? Okay, let me check. I think so. Now it's normal. Yeah. So now can you hear me properly? Yeah. Okay, so now I hope it will be okay. So basically, today's session, I will try to explain about that third desk topic, such as calculating any indices from satellite images using Landsat and Sentinel. Okay, so how we can easily use the Landsat and Sentinel satellite imagery and calculating the different types of indices such as NDVI, NWI, EVI, or SAVI, or any other indices, how we can easily calculate. We will discuss. As well as discuss about that how we can easily filtering and displaying the satellite images, mainly Sentinel-2. Previous class I discussed about that how we can easily work with Landsat satellite imagery. Today's session discuss about that how we can easily filtering and displaying the Sentinel-2 satellite imagery and monitor the NWI, NDVI, this type of indices. We also discuss about that thresholding technique, how we can easily apply the thresholding technique and extract the water body. We also discuss about that, as well as we also discuss about the time series chart. Okay, so different types of indices such as NDVI, then NDWI, other indices, how we can easily make the time series chart using Landsat or Sentinel imagery. Okay, how to explain a shapefile to discuss. Then how to add the gradient legend and title on Google Earth Engine, and how we can easily create the flood mapping using serial one star data. And we also discuss about the monthly time series chart of NDVI, NWI, or any other index how you can create. Okay, so let's go start one by one all of topic. So let me open my code editor. I think some network issue. Check. Yeah, please.
Hope you.
Yes, yes, yes. Today's really this is about also about that for flood mapping.
Yes.
How we can easily create.
Yeah.
Okay, I hope you can easily get the idea how we can easily work with the flood. No
Yeah.
problem.
Detection and also you mentioned that type of visual
Okay, I understand. Okay, okay.
hope give us a good idea.
Okay, I will explain. No problem. Okay, I face some problem on networking. Just a minute. Okay. So first of all, I try to explain about that how we can easily calculating any indices in Google Earth Engine. Okay. So different types of indices we already know, such as if you simply search on the Google, suppose I simply search remote sensing index, or indices, simply search on the Google, then you find out that lot of remote sensing. So you can also follow this PDF. So in this PDF, we find out that lot of indices, mainly different types of indices and their uses. Okay, set opening. Just a minute. So here you can see this is the PDF. I also send you that. You also read more details about that. For the different types of indices, how we can easily create and how we can easily calculate it. Okay, so then you can easily get at all of these details about that. Okay, so basically it explain about that different types of band. So for the Sentinel 2A, different types of band we can get it. So here you can see the coastal aerosol band, then blue band, green band, red band. Red was A1, red's 2 3, near infrared. So all of band we can easily access from the Sentinel 2. Also you can see about that say Landsat also. So all of Landsat data such as blue, green, red, near infrared, all of them we also get from here. And also you can see about that the different types of difference between the different types of band. You also read further more details. Okay, so now here you can see basically band ratio. So you can also use the different types of band ratio. to detect the different types of feature such as water body, or also use at that vegetation. So we are using at the different types of band ratio or spectral response and reflectance is similar from the two different objects. Then we can easily detect this type of things. Okay. So we also use at the band ratio to detect the different types of feature from our satellite imagery, as well as we also check the some band ratio look like that. Okay. So I also send you this PDF link. You also try to read. Then you also get the more better idea what's the band ratio, how we can easily use the different types of band ratio in our remote sensing project, and also work with that. Then you also get the more better idea, as well as you can check the difference between their histogram, such as near infrared reflectance represent more pixel frequency at high reflectance in near infrared signal 2 data. So then you can read this, you also get the lot better idea how it will work for the different types of band ratio. Okay, so basically we can use here the different types of indices. Okay, suppose you can see this is the one kind of indices. It's called the DVI. Okay, DVI means that mainly distinguish between soil and vegetation. It useful for the difference vegetation index. D for difference, V for vegetation, I for index. So basically this is the formula about the DVI, near infrared minus red. Okay, so when you apply this formula, near infrared minus red, you also get about the citation about this formula or equation. And basically this equation we can easily use to distinguish between the soil and vegetation. Okay, and does not deal with the atmospheric effect. Okay, this is when you use this formula DVI. Also you can see the RVI mainly ratio based vegetation index. So this is the formula about the ratio based vegetation index. So you also read this type of things further later, then you also get the more better idea and also learn how it will be work for the different types of indices. So here you can see this is the normalized difference vegetation index, NDVI, mainly near infrared minus red divided by near infrared plus red. So then we can easily calculate the normalized difference vegetation index, and it explains the density of vegetation. Okay, so we find out the healthy vegetation, we find out that high positive value, and stressed vegetation or sparse vegetation we find out the low positive value, and this is the formula about that for the NDVI. As well as if you check for different step of vegetation indices, different types of brains. So here you can see, so basically -1 to 0 is the dead plant or imminent object, 0 to 0.33 unhealthy plant, 0.3 to 0.66 moderate healthy plant, and 0.66 to 1 it very healthy plant. We can easily find out also about that. Okay, so not only for that, we also get the different types of indices, such as here you can see the SAVI. So this is the formula about the SAVI, near infrared minus red divided by near infrared plus red plus L, 1 plus L. So this is one kind of formula for SAVI. SAVI mainly soil adjusted vegetation index. Okay, the concept of the distinct way of vegetation from the soil background was proposed by this the Richardson. So this is the side he make the concept for SAVI, or mainly soil adjusted vegetation index. So it's one kind of index. So basically today's session I will try to explain how we can easily calculate this type of formula. Okay, and also calculate for soil vegetation index or NDVI. Not only for that, also you can see the water index, different types of water index we can also easily identify for NDWI. Okay, so you can easily get it this type of formula. Also you can see this type of graph for clear, moderate turbidity, very turbidity, brown. So this type of things we can also create the chart for the specific band. We also create this type of for the turbid water, what types of profiles for that moderate, clear, or very turbid or brown. We can easily get it from here also. Also you can see the Suno index. So different types of Suno index we are also use. So different types of index we are used in the remote sensing to identify for the different types of object. Suppose here you can see the vegetation index. So all of our vegetation index. Okay. So all of are the vegetation index. So first one is the ratio. Ratio you can see near infrared by red. We can easily get it for that biomass or leaf area index or vegetation cover. You can easily get it. Also you can see near infrared minus red. So different types of vegetation index we are used in the remote sensing for our different types of work. Okay. So now I will try to explain about that, how we can easily use the different types of calculate the different types of index in the Google Earth Engine. So basically, when you calculate the different types of indices in Google Earth Engine, first of all, you need to import your satellite imagery. If you want, you can import the Landsat, or if you want, you can also import the Sentinel. Okay, any one satellite image, both are the same process when you work with calculating for any indices in Google Earth Engine. So if you want, you can also work with the Landsat or Sentinel. Both are the same process. I want to work for suppose I want to work for that Landsat. Just click on the Landsat. So we also get the lot of Landsat image collection for the different time phase. I want to work for Landsat 8. Suppose Landsat 8, I want to work, and further I want to calculate the different types of indices. So here you can see surface reflectance, top of atmosphere. So basically when you monitor the different types of indices, different types of index, then it also better to use the top of atmosphere. So top of atmosphere provide you the more better result when you want to calculate the different types of index or indices. So I want to use this satellite imagery. So first of all, just simply copy the snippet ID and paste on your code editor. We already know about that. So let me increase my screen size. It also more better. Yeah. And further, I just give a variable name. Suppose I put the variable name is that L8. Okay. So now this is my image collection for Landsat top of atmosphere reflectance satellite imagery. So now I want to use this imagery, and further I want to calculate the different types of indices. So basically when you calculate the different types of indices, before that you need to create the satellite imagery. Okay, first step, you need to create the satellite imagery. So now I just simply import my satellite image collection. So this collection I need to filter. Okay, so we already know about that, how we can easily filter the satellite imagery. So different method I discussed in the second class. So let's go. I want to work for a specific study area. Suppose in this case, I just take the point. Suppose this is my study area. Just I click on here. This is my study area. So for this study area, I want to monitor any kinds of indices, and I put it. It's my ROI. Okay. So now first step is that first step you just filter your image collection. Okay. First step, filtering image collection and create a image. Okay, we create the image, filter the image collection, and then create a image. So for that, just I take a variable, suppose image. You can put any variable name, and I call the L8. Basically this variable store it the full image collection. Okay, then we already discussed about that different process for filtering. You already know. So first one is the filter bounce function. We already know about the filter bounce function. Filter bounce function mainly it intersection with your region of interest. So my is my ROI. Okay, so then we are just simply put the another factor. Suppose it's a filter metadata. Okay, suppose filter metadata. In this case, I just choose the cloud cover and put the operator. Suppose less than, I choose for 1, less than 1. Then further, just I take the another one. Suppose filter date. Basically for a specific time when you need this satellite imagery. Suppose I need this satellite image for year of 2024, 1st January from year of 2024 I just keep suppose 06 30. Okay, so between this time I just filter my image collection using filter bounds function. Filter bounds function is intersecting with your region of interest. Filter metadata function mainly filter image properties. I need the less than 1% cloud cover imagery. And filter date, this function help you to monitor for indices in a specific time period. So I put this type of time period. You can put any time period which you need. Further, I just check how much images are available for my study area. So I just call the image and then use the size function. So now we can easily find out. So here you can see it working. We find out the three images. Okay. So three images we find out. This three images is the less than 1% cloud cover. And this three images is available between this time period. And this three images is cover my study area. So this study area cover these three images. So now I want to use the another function. Suppose between this time period, I just need only a single image, and this single image will be very less cloud cover image. Okay, suppose between this time period for this study area, I just need a single image, and this single image will be less cloud cover image. So how I can filter it? So for that, we are just use the another function. Instead of the filter metadata function, we have to use the sort function. Okay, sort function. I want to sort using the cloud cover, and then I take the first image first. So now if I just print my image, so you can see just I print it. So now it provide me only for the one image. Okay, it provide me the only for one image, and this image is less than very less cloud cover image. So you can check all of information from here this image. So it's a one kind. You can see the type is the image. Okay, so it's a image, not image collection. I just take the single image, and this image information you can easily get it from the properties. So here you can see we find out the cloud cover level is the 0.04. Okay, so for this time period, we can easily find out which image is very less cloud covered image. We can easily find out using this way. Okay, not only for that, for any study area. Suppose I just simply click and drag it another place. Suppose for this study area, I want to find out less cloud cover imagery. Single, just only for the one image I need. And this image will be less cloud cover image. So for that, just apply the same process. When I run the code, you can see it just provide me a single image. Okay, and this single image is the less cloud cover image. If you want to check it, you can see we find out this type of imagery. So you can see the properties. We find out that 2.62 cloud cover for this study for this time. We find out in here. Also you can see about the acquisition time is that it's a single imagery. Okay, and this is the acquisition time, year of 2024 0528. So this is the acquisition time. So this is one kind of process. Suppose for any study area, you want to filter only for the one single image, and this image will be less cloud cover image. Okay, so which one is very less cloud cover image, it automatically provide you. So for that, just apply the sort and then take the first. Okay, then we can easily find out. So now I want to visualize it. Suppose I want to visualize this image. So for that, just use here map.add layer and call this image and click run. So now it will be loaded these tiles. You can see it find out these tiles. Okay, it just this type of image find out. Okay, so as for any study area, when you filter for a specific single image, and this image will be less cloud covered image, just apply the same process. Not only for that, for any other study area, just click on here. Suppose I need this image for this San Francisco, just I put in here. So now run the code. So now for this place, between this time period 2014 1st January to 2014 0630, I can easily find out the less cloud cover tiles. Okay, I can find out this type of tiles. Suppose this is my imagery. So it look like that because I don't apply any kinds of band combination. So that's why it look like that. So now I want to add the band combination. So let's go try to add the band combination. I already discussed about that. So just click on here, and I want to apply suppose band red, then green, and also put here the blue, and then custom stressing 98%. So now just apply. So now it added the true color composite. Okay, we can easily find out this type of imagery. Okay, this type of imagery. Just the import. It will be added a new. It just added a new variable. Just copy, and I just keep after the object name. I put it. Okay. So now this visualization is set it with my map view. So now this is my satellite imagery. Okay. So I find out my image. So now I want to use this image and calculate the different types of indices. Okay. So in this class, I will try to explain how you can calculate any index. Any index. Okay. So if you simply search any equation, suppose I simply search here EVI formula. So you can easily find out the EVI formula. You can see. So this is the, you also get some information also from here. You can see USGS website. We also get it from here, some information for the EVI. And what is the difference between the EVI and NDVI? You can also get it from here. You can see. So you can see this is the formula about the EVI. Okay, this is the formula. So this type of formula you can easily calculate. Okay, not only for that, any kinds of formula we can easily calculate. Suppose I simply search here SAVI, SAVI mainly soil adjusted vegetation. So I simply search SAVI index remote sensing. So you can easily find out. You can see Landsat soil adjusted vegetation. So now we can easily use this type of formula. Here you can see this is the formula about that SAVI for Landsat 8 and 9. So this is the formula about the SAVI. So when you just apply this formula, we can easily calculate it, the soil adjusted vegetation. Okay. So not only for that, there's a lot of indices we can calculate it using this process. So let's go try to calculate. So I already used this imagery. So now from this imagery, I want to use the different types of index or indices and extract the different types of information. Suppose if you want to use the information, suppose NDVI, I simply search NDVI. NDVI mainly normalized difference vegetation index. We already know about that. NDVI formula. I simply search. So here you can see the details about the NDVI for normalized difference vegetation index. So NDVI is one kind of index. Using the NDVI, we can easily detect the vegetation. Okay, we can easily find out the vegetation. So this is the NDVI formula. NDVI formula mainly near infrared minus red divided by near infrared plus red. So when you apply this formula on your satellite imagery, we can easily detect the vegetation. So let's go on example. I will show you that. Suppose I want to calculate this formula. So my formula is that, suppose I simply write the formula first, NDVI. So this formula is that near infrared minus red divided by near infrared plus red. So this is the formula. Okay. So I want to apply this formula on my satellite imagery, and further I want to extract the information for vegetation area. So I can easily detect the vegetated area. Okay. So let's go try to apply this formula. So let's go. So this formula we can apply the different way. Okay. So we can easily calculate this type of formula different way. First method, it's called the built-in function. Built-in function, basically normalized difference. Okay, so built-in, it's one kind of function, and this function is the normalized difference. So if I simply search the function in the docs tab, just if we simply search here, suppose normalized. I simply search normalized. So here you can easily find out this type of function. This function name is that normalized. Okay, normalized. And you can see we find out the function under the section ee.image. Okay, so ee.image, it means that this function I can apply only for the image. Okay, so this function normalized difference function I can only apply on the image. So that's why you can find out the ee.image. So if I just click on here, we can get the more details about that. So here you can see normalized difference. It's one kind of function. So compute the normalized difference between two band. Okay. So it's calculate only for the normalized difference between the two band, only for the two band. Okay. But some equation have more than two band. Here you can see such as soil adjusted vegetation. You can see band 5, band 4, band 5, band 4 also 0.5, also 1.5, this type of constant value. Also you can see for EVI band 5, 2.5, band 5, band 4, band 5. So this is the limitation about, suppose this normalized difference function only computed normalized difference between the two band, just near infrared band and red band. Okay, so this type of formula we can easily work with this function, normalized difference function, because in the NDVI formula we can easily get only for the two band, near infrared band and red band. Okay, as well as if you check for another formula, suppose NDWI formula, I simply search, mainly it's the normalized difference water index. So here you can see this is the normalized difference water index formula. Suppose I simply search, simply open it from here. I try to open it from a research paper. It formula, yeah. So this is the formula for, you can see the lot of formula, you can easily get it. And this type of formula we can also use for the land cover classification. Okay, so basically when you use this type of vegetation index or water index or build up index or barren soil index, so when you apply this type of index in your land cover classification, then we also get the more better accuracy. So for the land cover classes, I will try to explain about that, how we can easily work with that. So now we try to discuss about that, how we can easily calculate this type of equation. So here you can see for NDWI, green minus near infrared divided green plus near infrared. So this is the formula. So this is the another formula, green minus near infrared divided by green plus near infrared. So I also write the formula also in here in my code. Suppose I just make the comment. Suppose NDWI. NDWI. So this formula is that green minus near infrared divided by green plus near infrared. So this is the formula for green minus near divided by green plus near. So this is the NDWI, mainly normalized difference water index. So this formula, when I apply on my satellite imagery, then I can easily detect the water body. Okay, on the surface water body, I can easily find out when I apply this type of formula. Okay, so this is the function, normalized difference function, and this function only compute the normalized difference between two band. Okay, only for the two band. So now I want to apply this function and then calculate the NDWI or NDVI. So let's go, we try to calculate it. So for calculating these things, just I take a variable. Suppose I put the variable name is that NDVI, NDVI, and now I want to apply the built-in function on my satellite image. Okay, so because this function only applicable for the ee.image. So now I already create this type of image. So this is my image. So just I call the image. So this is my image. I simply copy. I already make the image. I simply call the image. And then paste here. And now I apply the function normalized difference. So just I write normalized. So now I put here the band name. Okay, normalized difference between two band. Okay, and it computed, you can see the normalized difference is computed as first minus second divided by first plus second. Okay, so in this case first band is the near infrared band. Here you can see the near infrared band and red band. So just I mention here the near infrared band B5 and red band mainly B4. Okay, you can get this type of information from your satellite imagery. Here you can see the band 5 is the near infrared and band 4 is the red band. Okay, so now I apply this function in here. So now it computed the NDVI. So now let's check the exam visualization. Just I add the layer map.add layer and put here NDVI. Click run. So now it computed the NDVI. Very easy. Okay. Using this process, we can easily compute it, the NDVI. So it look like as a grayscale. Okay, but you can easily add the color. Then you also get the more better map. So how I can add the color? For adding the color, if you want, you can simply click on here and then just stressing it. Suppose I just keep the stressing as a 98%, and I want to put the color. Suppose I want to put the color for okay, just a minute. I just click on here. Related, I just I think some problem in my mouse. Just a minute. I try to write it randomly. Suppose I just make a dictionary. I put at the mean value and also put at the max value. Okay, and I also put at the plated. I put the color, suppose blue color for low vegetation, then white color, and vegetation for green I put in here. So now this mean and max value I can easily generate from here. Suppose I just try to keep it for 98%. So it automatically provide me the minimum range. I copy and paste here. And also maximum range, I just copy and paste here. So now run the code. So now this color is also set it. So this is the another way to adding the color on your satellite imagery. So now you can see you can easily get this type of information, this type of map we can easily generate. So now we can easily find out this type of green color pixel indicating about that vegetation area. Okay, and this type of water color, mainly blue color, indicating the water pixel. And this type of pixel value will be negative. If you want to check the value, suppose just open the inspector tab and click on the water body. So you can easily find out this value. You can see for water, it show the negative. Okay, we can easily find out it's a negative value because for the NDVI, normalized difference vegetation index, we find out that water body as a negative pixel. Okay, and vegetation, if I just click on the vegetated area, then we can get the positive value. Okay, and high positive value indicating the high vegetation. Here you can see find the 0.6. So this is the indicating about the high vegetation or high vegetated area. We can easily find out from here. So this is the one process. We can use the built-in function, mainly normalized difference, and we can compute it this type of formula. Okay, this type of formula NDVI. So now let's check the another example for NDWI. NDWI mainly normalized difference water index. So this formula help me to detect the water body on the surface. So let's go try to apply it. Same process we apply. Just take a variable NDWI and I call this image and apply the normalized between two band, green band mainly B3 and near infrared band B5. Okay, so just I mention the band name B3 and and B5 near infrared band. So now this function, basically this function computed as B3 minus B5 divided by B3 plus B5 and computed the NDWI. Okay, so let's go try to write. I just put here map dot add layer and call the NDWI. So now NDWI is ready. We can find out this type of gray color. So I want to add the color. For adding the color, just make a dictionary. I put at the mean value, mean, and also put at the max, and also put at the plated. So for the plated, I want to show, suppose basically for the NDWI, positive pixel indicating for water body, and negative pixel, it can be vegetation or barren land. So I put in here, suppose green. Then I put here, suppose yellow, and I put here, suppose as a blue for water, positive value. And I mention the mean and max value from here, this layer. Just I keep stressing 98%. So it automatically provide me this type of value. Just copy and I paste here, and also copy and paste here. So now it created the two layer. One is the NDVI, another is the NDWI. So let's go to check it. Okay. So here again, so you can find out this type of map for two map. One map is NDVI, another map is for NDWI. Okay. So you can easily use this type of indices. So this is our vegetation index map. So vegetation index map mainly help you to detect the vegetation area. And NDWI, this is the NDWI map. We can easily detect the water body, surface water. We can easily detect the water body. Okay. So if I check, suppose just I click on the pixel value, you can see. Just I click on this water body. Just I click. So when I click on this value, it also show me the pixel value. So here you can say I can get the two types of value. For the NDVI, we find out the negative pixel. Okay, this is the negative pixel for NDVI. And 0.6 for positive, it show for NDWI. Okay, so for the NDWI, we find out that positive pixel value and high positive value indicating about the high density of water. Okay, and low positive value, no, it's indicating about the low density of water. Okay, but for the NDVI, for the water body pixel, show as a negative pixel. We can find out the negative 0.54. Okay, so this is the process about that for calculating the indices, which indices have only for the two band, near infrared red, green, and near infrared. But some indices have this type of formula. Suppose here you can see I want to calculate for, suppose this equation. Here you can see the SAVI. Yes, SAVI. So when you apply this type of function, you want to calculate, then normalized difference function cannot be worked. Okay, normalized difference function only work for which index only have two band, such as NDVI. NDVI only have the two band, near infrared and red. Only for NDWI, green and near infrared. But when you calculate this type of index, suppose here you can see I want to calculate this index, SAVI. Mainly this formula is that for Landsat 8 and 9, same formula, band 5 minus band 4 divided by band 5 plus band 4 plus 0.5, also multiply 1.5. So when you calculate this type of formula, SAVI, then normalized difference function cannot be worked. Then we have to apply the another function. Okay, so it's called the expression function. So I simply search here, expression. So here you can see expression. Okay, an expression function only work for image, ee.image. So that's why it show the ee.image. So expression. So here you can see evaluate an arithmetic expression. Okay, we can easily apply the arithmetic expression on an image, possibly involving the additional images. So now we try to use this function expression, and we put here the expression. So let's go try to read. So for that, just I take a variable, suppose Savi, and I call my image, because this variable is stored in my satellite imagery. Okay, and I want to apply for expression, and I put here my arithmetic expression. Basically this type of arithmetic expression, which is including the positive, negative, multiply or division, this type of sign. So I want to apply here these things. Suppose band 5 minus band 4 divided by band 5 plus band 4 plus 0.5, then put here multiply 1.5. So just I put here the arithmetic expression. So this is the arithmetic expression. Arithmetic means that we including the negative, positive, multiplication or division symbol, and then we make this type of equation. So just I put my equation band 5 minus band 4 divided by band 5 plus band 4 plus 0.5, then multiply 1.5. So this equation I just put in here, and now put here the comma sign and make a dictionary. So in this dictionary, you need to define what is the band 5, what is the band 4. We need to define it, because in this arithmetic equation, you can find out 0.5 and 1.5 is a constant value, but band 5, band 4 is not the constant, it's just a variable. Okay, so we define it, what is the band 5. So just I put here call the band 5, and I just use my image and select the band 5. Band 5 mainly B5. Okay, near infrared band. Then I call the band 4. I call the image and select the B4. Okay, so now it's done. Okay, and 0.5, 1.5, it's a constant value, not need to add anything in here. So now we try to add the layer. So for adding the layer, just call the map.add layer and call the Savi, click run. So now it added the soil adjusted vegetation index. Okay, so it added the layer. You can see it added the layer, this type of soil adjusted vegetation index we can easily add in here. Okay, so basically this is the process when you calculate any index. Okay, just we apply these two process. One is the normalized difference function. Normalized difference function only work for two band. Okay, but expression function, this expression function work for any kinds of arithmetic equation. Okay, suppose I want to calculate the NDVI using the expression. So how I can do it? I will show the another example. So just I write the code in here. Just take a variable, suppose NDVI, and I call my image. Okay, I want to apply for expression, and my expression is that I write the expression mainly. I write the arithmetic near minus red divided by near plus red. So now I need to define what is the near. So I just make the keyword and key value. Suppose just I make the keyword near. Near mainly come from my image and select for a specific band. Okay, select for B5. Okay, then what is the red? So just I put the red and I define what is the red. red mainly come from my image and select for before. Okay, we have to use here the curly bracket after comma sign. Just put here the curly bracket start and also curly bracket end. Okay, now it will work. Now, so now it all easily calculated for NDVI also. Okay, just we are applying this type of things. If you want to also add the map.add layer and call the NDVI. NDVI. Okay, so this is the process. Okay, so any kinds of equation we can easily calculate. So you also try. I also give you an assignment. Suppose you try to calculate the EVI mainly enhanced vegetation index. So this is the formula. So you try to solve this formula and then make the map of EVI mainly enhanced vegetation index. So using the same formula, okay, suppose you try to solve this formula. This formula is the 2.5. It's multiply with band 5, then subtract with band 4 divided by band 5 plus 6. It's multiply with band 4, then subtract with 7.5, then band multiply with band 2, okay, then plus 1. So you try to calculate this formula and then try to make the map for EVI. Not only for that, any kinds of index, any kinds of equation, using this process you can calculate. Okay, so now any question you can ask me, please. Any question for calculating the index? Okay, I hope there is no question. Okay, also try further. Face any problem, then I also guide you, no problem. Okay, so this is very easy process. So first of all, we need a image. Okay, for Landsat or Sentinel, both are the same process. We need a satellite image. So for that, I create this type of satellite imagery. Okay, so this satellite imagery, I just apply different types of index such as NDVI, NDWI, SAVI, or EVI, or any other index. I just apply and extract the different information. Such as first one is that NDVI. Okay, so NDVI give me the information for vegetation. We can easily detect where the vegetation is high, where the vegetation density is the low. We can easily detect about that. Second one is for NDWI. So NWI, it's very easy. We can easily detect the water body on the surface. Where is the high density of the water? Where is the low density of the water? We can easily detect. Then we also discuss about the SAVI. SAVI mainly soil adjusted vegetation. As well as we also discuss about the another for NDVI again. We also discuss about that. Not only for that, you can get all of details for the different types of index. You also get it from here. Also, you can see the drought severity index. So you also try to calculate this type of things. Okay, drought assessment. Suppose we can apply the NDVI, then drought severity index or vegetation condition index. You also try to calculate this type of things. You also try to calculate. Further face any problem, they also guide you, no problem. So first of all, you try. Okay, as well as you also try to calculate for different types. So you can see the automated water extraction index. Also, you can see the modified normalized difference water index or normalized difference water index. Okay, then superfine water index SWI. So you also try to read this full paper and also try to calculate this type of index. Then it also more better practice for your learning. Okay, so also try and also read this paper. I'll also send you that and try to calculate all of index. All of index you try to calculate. Okay, and also try to make the map. So I will show you that how we can easily make the time series chart after some time. Okay, so any question you can ask me. Also, you can see this is the vegetation condition index VCI. Okay, NDVI minus NDVI minimum value divided by NDVI max value minus NDVI mean value, then multiply with 100. Then we can easily detect about the vegetation condition index, and lower and higher values indicate the bad and good vegetation state condition. Okay, lower and higher values indicate the bad and good vegetation state condition. We can easily get it from here. So I also send you this PDF also. You also try to read and further also apply and calculate the different types of index. Yeah, please, any question?
Yes, sir. Just when we make or any type of using accuracy assessment,
Okay.
that's our result.
Okay, understood. Yeah, yeah.
Okay, right or
So for accuracy assessment, we try to use the machine learning. Okay. So in this case, we are just applying the index, and we can detect the water body, or we can detect the vegetation or any other specific feature from our satellite imagery. But further, when you want to check what the accuracy, okay, so then further we also need to apply the machine learning model. Okay, so these things I'll try to explain about our land use land cover classification map when I discuss about that. So you can easily get the idea after creating this type of map how we can easily apply the machine learning. Suppose we also combine all of NDVI, NWI, or SAVI, or any other indices. We can also combine, and further this type of things we can also apply for the land use land cover classification and also check the accuracy. So this type of process further class mainly I discuss about that 6 number class. For that, how we can easily check the accuracy after making the land use land cover classification, and identify for vegetation or any other feature from the satellite imagery. So then I hope you can easily get the idea how we can easily check the accuracy after creating this type of map. Okay, so it's also possible to check the accuracy. No problem. Okay, so now I hope we can get the clear concept about that, how we can easily calculate any index, not only for a specific one index, any index. You also try. If you face any problem for calculating any specific index for calculation, just let me know. Then I also try to guide you how we can easily solve this problem. Okay, so now let's go another. Okay, so let me open my code. So now we will try to explain about that how we can really identify for water logging area. Okay, so in the rainy season we can also face this type of water logging problem in our urban area. Okay, so in the urban area we can easily find out some water body in the rainy season, and it's called the water logging problem. So today I will also discuss about that how we can easily detect the water logging area in our specific city, and we try to compare the result. Suppose summer season and rainy season, or summer season and rainy season, what the scenario of land water logging area. Okay, and we also try to identify, as well as we also try to calculate the area of water logging. Okay, using the water index. Okay, so if you simply search on the Google water index, you can get a lot of formula. So just a minute, I try to open it. I simply search water index formula. I simply search. So you can easily find out the different types of water index. So just I try to open it. So here you can see different types of water index. We can easily find out from here. Such as one kind of formula is that NDWI. Okay, so this is the formula about the NDWI. Okay, so and used for monitoring the changes in water content in level. Okay, leaves an analysis of the susceptibility study area for to fires, monitoring the plant fertility, detection of the surface water, some areas, measuring the extent of the coverage by surface waters. Also you can see they also create the map. Okay, this is the formula water ratio index, WRI. So WRI, this is the formula about the WRI. Also you can see about the another formula, this formula mainly for MNDWI. MNDWI formula is that green minus short divided 2 divided by green plus short divided 2. So different types of water index formula we can use in the remote sensing and detect the water body. Okay, and there are a lot of uses for the different parameter or different index have the different uses. So you also try to read this article, then you can also get a little more better idea which index is more better for your project, for your specific work. Okay, so let's go try to discuss about that, how we can easily create. So in this case, I want to work for Sentinel-2 satellite imagery. Okay, so just I try to click on the Sentinel and try to find out the Sentinel-2 satellite imagery. Then I want to for Sentinel-2 multi-spectral instrument. I want to work. In the Sentinel-2, we can easily find out the top of atmosphere. I want to work for that. So now I want to use this satellite imagery and I want to identify what are logging area in a specific city. And I want to compare the result to city, mainly two time period, summer season and rainy season. Then try to identify for change detection. So first of all, just copy this snippet from here and then paste. Then give a variable name. I put the name, suppose Sentinel-2 equal. So now this is my image collection. Okay. So this image collection, I just store it in this variable name as a Sentinel-2. So now I want to filter this image collection to time period, such as summer season and rainy season. So for that, I just take a variable, suppose dry, image. I take a variable look like that for dry season. I just call this variable name Sentinel-2 and paste here. So I just filter, suppose filter bounds with my study area. So in this case, I want to work for suppose Dhaka city boundary. Just I try to import it for Dhaka city boundary. Just import. And then I put the name as the RY. Okay, so I need this satellite image for this RY. So just I intersection with my study area using filter bounds function. And then just I put here filter, suppose filter metadata I want to choose. And I just apply for a specific image properties. Suppose I want to apply for cloud pixel percentage. Just copy and then paste here. And I choose, suppose I choose for less than, and I put suppose 1. And then filter date for a specific time. Suppose I need this satellite imagery for dry season, year of 2023. So 2023. So 1st January from 2023 for Dhaka city region, mainly Bangladesh. We try to keep it for dry season 05 this time period. We try to keep as a dry season. So now if you want to check how much image is available between this time, first of all check it. So dry image, use here the size function. So now on the code. So now it computed, we find out the 25 images are available in your satellite, in your study area. These 25 images are available in the dry season, and this 25 images is the less than 1% cloud cover. So now I want to use it and then make the median composite and further flip with my study area, which is RY. So now just try to add the layer. So just map.add layer and call the dry image. Okay, so now we also try to focus on the center of this boundary shapefile. Map dot center object. Object is ROI. Do label substand and click run. So now it center focus on my given study area, as well as also display the satellite imagery. We find out this type of imagery. To put suppose red and green, green and blue. Customer stress 98%. And apply. So now it will be added in my code and also import. Then copy this variable name and paste here. I put the layer name. It's a dry image. So now I got one image for the dry season, but I need the another image for the rainy season. So just I keep the copy the same code. So just I try to put in here suppose 2023 06 10 30, and I change the layer name. I was waiting. And I just copy the variable name and paste here. And I put here for now we can easily add the band combination for the white image also. Red, green, and blue. And apply. So if I now also import, so just we try to copy and then paste after the object name. And now just wait. And on the code. So now I can easily get this result. So in this result, we can easily find out the two satellite imagery. One is for dry season, another is for rainy season. So you find out this type of imagery. Here you can see this is the difference between the two satellite imagery. One is the dry, another is the wet. Okay. So now we try to check for what is the scenario for water body in the two time period. One is the dry season and rainy season. Okay. So now in this two satellite imagery, you can apply the two index. Suppose water I want to detect from the two satellite imagery for the dry and wet. Okay. For the dry and wet, I want to detect the water body. So now we can easily apply. We already learned about that, how we can easily detect the water body. Okay, so different types of formula I can use. So one formula is the NDWI. Suppose I want to use this formula for NDWI. Green minus near infrared divided by green plus near infrared. I want to apply. So for that, we try to put in here. Just I put here suppose NDWI is that green minus near infrared divided by green plus near infrared. So just I take a variable and I have to calculate for NDWI for the two season, dry season and rainy season. So I want to put here for suppose NDWI for dry, and I call the image. Just I call the image. I call the dry image and paste here. And now we want to create. Now we want to just calculate this equation. We already know about that how we can easily calculate. We are apply the normalized difference function. Normalized difference. And I put at the green and near infrared. Green mainly B3, near infrared mainly B5. Okay. So now and paste it. So now we try to run the code. Just I click on here. Stressing. Just I click on the and I want to click in here. Suppose red, YOLO. Suppose I put this. I'll put at the blue. So now we put at the YOLO, red, YOLO, green, and blue, and then apply. So now it will be set it with our map. Okay, and also import. It import it. Just copy the variable name and set after the object name. Just I set here, and I put the layer name. Suppose NDWI dry. Okay. So now we can easily find out that dry season NDWI, mainly water body. So this type of blue color, if you want to check it, there again, so you can get it this type of blue color, blue color, blue color. It's water body, and this is the scenario of NWI in dry season. Okay, so now try to check for rainy season. What the scenario of the rainy season? We try to check it. So just I try to take a variable. Suppose NDWI. Wait. So just call the wet season image. I call the wet season image and paste and copy. Normalize difference. Layer. NWI wait. Copy and paste. Okay, now run the code. So now we try to keep for just add the color. So we try to keep the same color, then it will be more better. It's testing 98%. And I try to keep suppose red, YOLO, and suppose green. And apply. And then import. And further just keep and NDWI or suppose wait. So now we find out the two time period or two season in AWI. So now we try to make the water logging area. Okay. So here you can see NWI weight. So this is the NWI weight. Weight mainly we find out that rainy season. What is the scenario of the NWI map? We find out this type of things you can see. And you can see there is no water body. In the dry season, there is no water body. And the rainy season, you find out the water body. You can see the difference. So you can see in this place, there is no water body in the dry season. Okay. But the rainy season, you find out that water body. Okay, you find out this type of water body. Also, you can see, you find out this type of water body in the rainy season. Okay. So if you check it for dry season, there is no water body. There is no water body. Okay. But in the rainy season, you find out that water body. So it also more better you can understand about that. Suppose if I check the pixel value. Okay. Suppose I want to check the pixel value from inspector tab. Just click on here and then click on this water pixel. So now it shows this water pixel. So here you can see the water pixel. So here you can see, find out that for the rainy wet season, we find out that high positive value. Okay, high positive value 0.1, and dry season very less positive value 0.0003773. So it means that this water is available but not mass. Okay, and 0.16 means that it's that more greater than for this value. So it means that it also water body is available more than dry season. Okay, in the rainy season you find out the more water body than dry season. So let's check for other place. Suppose I just click on here. So you can find out, you can see negative pixel. Negative pixel means that there is no water. In the dry season, there is no water. But rainy season, we find out that water body, positive value. Okay. So basically in AWI, positive negative value indicating there is no water, and positive value indicating about that water body is available. So we find out that 0.22, this pixel is available in the rainy season. It means that water body is available in the rainy season, but there is no water body in the dry season because it shows the negative pixel value. Okay. So this type of concept we can also use in the for flood mapping also. Suppose for the flood mapping, we can just take the two images for before flood and after flood. Then we check the pixel value. Okay. So I will show you the one example. Just I try to show you that, or and then explain about that. Let me open for let me open this code. Let me run the code. So this is the one kind of code. So here you can see. I will try to explain after some time. So in this code, we are just use here the Sentinel-1 SAR data. Okay. So this SAR data, we find out, get the two time period. Okay. One is the after flood, another is the before flood. So here you can see. So this is the before flood condition. This is the before flood condition. Okay. And this type of black color or dark color pixel indicating about that water body pixel. Okay. And this is the scenario of before flood condition for this very area. And after flood condition, you find out this type of pixel. Okay. Lot of water pixel, black color water pixel, lot of it increased. It increased. it increased. It increased, you can see. Okay, so same process. Suppose dry season and rainy season. So in this case, we take the before flood and after flood. Okay, and then we are just identify for flood inundation area based on the thresholding technique, and also permanent water body area. Okay, so now how I can find out the flood inundation water, and also separate, mean how I can distinguish between the permanent water body, and also also identify for the flood water body. Okay, which is not permanent, it's the overflow of water on the surface. Okay, so this is the flood water, and this is a permanent water body. So how I can distinguish? So in this time I try to discuss about that, how we can easily apply this specific thresholding technique, and then we can easily detect the flood water and permanent water. So let's go. So this thing we also try to apply also in here. Then we try to apply in our flood code. So in this case, we try to use this satellite imagery, and we already make the Q map for different season, dry season and summer season. And then we try to make the NWI dry season map and also NWI wet season map. Okay. So now we try to check some pixel value. Okay. Suppose I just simply open. I try to check the pixel value from the permanent water body. Okay. Suppose this is the one kind of permanent water body. So in the permanent water body, I want to check. Just I click on here, and then check what the pixel we can find out. We find out the 0.07. Then click the some other place and check the value. Randomly, you can check some pixel value from your study area. You find out the dry 0.08 and wet 0.06. Check suppose others. Find out the 0.03. Also find the 0.09. Okay.